So here's GPRPy, and I'm loading in some data that we collected in an area where there were animal burrows. And I must admit I can't actually remember the rock type, possibly lavas or quartzite. I think it must have been quartzite, I'm not actually sure. So I'm going here to import data, and here's my data, and I'm loading in a DZT file because it was collected with a GSSI antenna. And I click open, and you don't see much, which is worrying. You can see a faint line over here. I'm assuming that just means it's poor reflections. And so I'm just going to edit the contrast here. I've typed in 10,000. So I typed, I think in the videos, because there's great videos by the guys from GPRPy, they recommended like, okay, well there's 100, you're seeing that. And let's do a few more to see if we can see deeper. Okay, let's take away some of that. And you can see there is some sort of things going on at depth. From what I understand, this is the ground roll and the air roll and the ground roll. That is swamping the signal. And so we are going to go along here and click on remove mean trace. And they suggested in the video making this number large. I'm going to make it 900,000. So it takes an average over the whole area to get rid of these. And click OK. And you can see quite a bit of information, or quite a bit of that like swamping signal is gone from those two, the ground roll and the, sorry, I think I said air roll and ground roll. I meant air wave and ground wave. And so once I've removed it, there's this large area up here that doesn't seem to have signal. So in the online videos the GPRPy guys did, they first, before applying this filter, shifted the data up if there was a gap. They didn't shift it after removing the filter, but to me it seems necessary to shift it up now. But I don't know if I'm affecting things because actually this is part of the ground. But I don't think so. I think this might then have been impacted by how high we had the antenna off the ground. I'm not 100% sure. So I'm going to click here, and you can see as soon as I click, it shows me what the value is here that I start getting signal. So at around 8.6. And then I go here, and I go set 0 time. I'm going to do 8.6 because it's not exact everywhere. I do that and it shifts everything up. And you see as soon as it shifts it up, this high contrast, because we no longer have that white at the top, is too much. So I'm going to drop it back here to 1, which is too little. And let's make it 10. And let's try and make it 100. And yeah, I'm not sure what was going on in the edge here. And sadly, this is not the greatest profile considering the fact we actually did see some animal burrows along here. So you can also cut off the bottom here. So I'm going to do that. So I'm going to say truncate Y, and I'm going to cut it off at 40. And it just gets rid of all the data below that so that it doesn't take up memory in your computer. And now I've gone up here and clicked set Y range, and I'm going to make that 40. So, sorry, I shouldn't have done that. Set Y range 0 and 40 maximum so that it stretches the data down. Although I'm not actually 100% sure if it's worth doing that, because sometimes it makes it more difficult to see what's going on. So your choice whether you actually want to go do this. I mean, the data looks even worse now that I've done this. So that is one thing that you can do there. Another thing we can do is if I take away this contrast, we can look at the gains, applying gains. So T-PAL, if I remember, they used a value of 1 in the videos. I'm sure you can come along. I found sometimes I can't always undo stuff, but maybe I'm doing something wrong. We do 2. So it's kind of a similar effect as the contrast, but you're applying gains. So let's try that. And now the other gains is the AGC, and I think they said a value of about 100. And so yeah, I'm not sure if either of them is any better than the other. And let's see again with the contrast. It's interesting to see the changes at shallow depth. Sorry, I forget that you have to change the contrast back there. Let's maybe try back here, T-PAL. So, okay, so it's quite interesting. With the contrast, it's really bringing out these shallower levels, whereas with the TPAL, everything is equally being brought up. So I'm actually going to pause, take the 3 screenshots so we can compare them. Okay, well, these are the 3 together. Top left is the change in contrast, then it's TPAL, and then it's AGC. I'd say, I don't know, TPAL maybe. The AGC still brings out a lot more of the shallower stuff, as the TPAL seems to be uniform. But they do say in the videos to try that different things will work better for different data sets. Okay, so let's go back to our data here. Okay. Okay, and so this is the data, and you can print a figure. I haven't tried this before, so I'm going to say line 5. And it's always a good idea to record what you did. So we removed mean, and we did, what did I say, to the T-power of 2. I also actually shifted it up. What's it called? Okay, the first thing we actually did was 0 time of about 8.6. Okay, that should be everything that we did to it. So it's a really good idea to just keep track of that. I didn't actually watch properly in the video. I don't know if I'm supposed to give a file extension. Let's try. Resolution of dots per inch. For now, it's a tough one. We don't want your things to be too big. I'm going to put 300 and see what happens. Okay, and I don't actually know where I saved it to. Sorry, yeah, it was in this folder. Let's see how big that came out. Okay, and what it looks like. What's up? Who knows what I'll say to that. Okay, let me go back and go just figure that out. All right. Okay, I think the problem was I shouldn't have put an extension there. So let's go there, take out the extension, and click save. And I'm going to put 300 dots per inch again. And let's go back. Oh, sorry, I did read it, that it saves it as a PDF file. Which is great, how good it looks. So that was 300 dots per inch. I would probably increase it. The resolution doesn't look the best, but let's see what size. It's not unreasonable file size, and then you can always take a screenshot of that. Something I forgot to do here was actually to work on changing the time to depth, which is not going to be easy considering the fact we don't have very easy hyperbola here. Let's assume that this is a hyperbola. There's this huge thing here, but we're not over the hyperbola, so it's difficult to plot. So let's use this one. I don't know if it's 100% right because I was doing this on another profile. The hyperbola were a lot sharper. So let's at least just show the methodology here. So I'm going to click on the apex of the hyperbola. I'm going to see the values up here. I'm going to say, show hyperbola. And I'm going to define the distance, which is 1.6824, and the y value is 14.63, and I click OK. And then you've got to estimate the velocity. This velocity, they used a similar one of 0.1 in the video. I think this is going to be a lot more. Let's try 0.15. You can see that's too narrow. I don't really think this is a good hyperbola to pick. So anyway, even that's not enough. So each time I'm increasing the velocity. That's not too bad. So 0.3. And then you would go here and set velocity to 0.3, and it will now convert your y-axis from time to depth. Okay. And so, yeah, now you would want to print your figure. Go over here and save, replace. Okay. And let's save the data. I'm going to use the same file naming system as I did for my image. And click save, and let's double check that it saved it here. Yeah, we've got a file here. So this in general is the process that was described in the videos by the GPRPy guys. I'm just not sure if I did it right, that I shifted mine up after I removed the air wave and the ground wave.